What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm back again to drop some more math jewels. Nah, whatever. But we're going to talk about intervals today. Intervals like spaces, blanks and things like that. So, intervals is a cool topic tonight. I think I'm just making videos on cool topics that I like. And I kind of dug into my what I call book of rhymes, which is where I take my notes from my videos. But anyway, intervals. Let's talk about there's two types of intervals. There are open intervals. Okay? There are open intervals, and open intervals look like this. Okay? Now, I'm going to use the variables a and b. So an open interval looks like this. Okay? It's an open interval, and you'll see what that means. And there's another way we can write this in interval notation, or it looks like this. And this is going to look like a foreign language to some people if you've seen it in your book. Let's say a. Okay? So what this is an open interval, and this means the set of all x such that a is less than x, which is less than b. Okay? So that means that a and b are not included in your actual solution, and you'll see when we do the examples in just a second. Okay? And then we have closed intervals. And these are typically used with inequalities, a few other things. Closed intervals look like this. Okay? So closed interval might say set of all x such that a is less than or equal to x is less than or equal to b. Okay? So here's the difference. So once again, this one is, notice these are brackets on these letters. These ones have parentheses. Closed interval looks like this. The set of all x such that a is less than or equal to x, which is less than or equal to b. So the difference is a and b, in this case, when it has the brackets around it, are included in your solution set. That's why it's a closed interval. A and b in this case are not included in your solution set, so it's an open interval. Now, here's one tip I want to give you with closed intervals and open intervals. I want to talk to you about infinity, because infinity a lot of times can be in your answer. So let's say you're working with an inequality and your solution is x is greater than 5. Well, that is any number greater than 5. So the answer is from 5 is any number greater than 5 would go to infinity. Any number less than 5 would go to negative infinity. So we have two open intervals. So one looks like this. Okay? So this is an open interval which tells me the set of all x, or technically the set of all a, such that x is greater than a. Okay? So when I have this number a, remember a represents a number. Okay? So in the example that I just spoke of, I said 5. So let's say a is 5. This tells me the set of all x such that x is greater than 5 in this case. All right? And then we have like another one for negative infinity. Okay? So let's say I have from negative infinity to a. So this tells me the set of all x such that x is less than a. Okay? So if we were using 5 again for a, this tells me all the numbers less than 5. Okay? Remember, it goes to negative infinity if we're talking about less than. It goes to positive infinity if we're talking about greater than. This is just another form of open interval. Let's actually do some examples to where you can make it make sense. So in this video, I'm going to keep it simple. I'm going to just show a open or a closed interval. and then I'm going to basically show it in two different forms. So let's look at example one. All right, example one says, let's say if I have, we'll give it in this form. Now remember, do not confuse these with ordered pairs. You will know that it's not an ordered pair because when you're going through the unit, you're going to see that this is interval notation. Okay, so what this looks like is this is the interval from -3 to 0. Okay, or -3 to 0. Now I can write it saying like this. I can say the set of all x such that x such that -3 is less than x, which is less than 0. Okay, so x is between -3 and 0. Notice this is an open interval, so -3 is not included in my solution, and 0 is not included in my solution. Okay, very, very important. It's parentheses, so it's an open interval. So -3 and 0 are not included in my solution. Let's look at another example. And of course, I'm definitely going to have another video available to you to make this make sense. In the meantime, you can look at the inequality videos to help this make sense as well. So if I have example 2, and let's say I have the interval here, 2 to 8. Notice there's an open interval on the left side, a closed interval on the right side. Well, the way that we write that is we say the set of all x such that 2 is less than x, which is less than or equal to 8. Okay? What does this mean? Remember, here the 2 is not included in my solution, so it's just less than. Here the 8 is a closed interval, so it is included in my solution. All right? So it's less than or equal to. Okay? Very, 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 very important. All right? Let's do one more example. I hope this stuff is making sense to you. I know sometimes people, I've heard so many complaints about people having instructors that don't break it down, and that's part of the reason why I do these videos. Let's say I have this right here. Let's say 4 to infinity. Now, whenever you have infinity or negative infinity, it will always be an open interval because it keeps going and going and going. And I love telling students when they ask me about big numbers, I love telling them, well, there's a mathematical rule that says for every number x that exists, there also exists x plus 1. And so they'll try to say this large, crazy number. Half of the time they say it wrong. All right, so this right here is the set of all x such that 4 is less than or equal to x, which is less than infinity. Okay? 4, actually, I'm sorry, I wrote that wrong. I totally wrote that wrong. This actually is saying, we write this one like this. The set of all x such that x is less than or equal to 4. I wrote that wrong, okay? No, it's not less than or equal to. It's greater than. Whoa, what in the world is going on? I told y'all, hey, listen, I am not re-recording this. Let y'all know I'm not perfect. I'm a mathematician, been doing this for several years, but I still make mistakes. All right. In this case, it's actually x is greater than or equal to 4. I'm sorry for that mistake. All right, and the reason that I know that is because 4 is here on the left side, and then the number on the right side is going to be larger than that. Think about it in terms of a number line. When you go to the right on the number line, the numbers get larger. Okay, so this is definitely x is greater than or equal to 4. Notice it's greater than or equal to because this has a closed interval on it. So that tells me that 4 is included. Remember also, infinity is always an open interval. One last one. I didn't put this one in my notes, but let's say if I had this right here. All right, let's do this one. All right, from negative infinity to -2. What this tells me is the set of all x such that x is less than or equal to -2. Okay? Still an open interval on the negative infinity side. Okay? But here, the -2 is included because it's a closed interval. So this is x is less than or equal to -2. Thank you so much for watching. Remember, like, share, subscribe. Tell your friends about it. Thank you so much. Follow me on Instagram, Young Gurus _Math Tutoring. Facebook, Young Gurus Math Tutoring. Thank you so much for everyone that has been watching and rolling with me in these past couple of years of doing this. And remember, I've got the solution to your math problems.